Assalamualaikum and hi everyone. So today I would like to share about Newton's universal law of gravitation and circular orbit 2. So firstly, we must understand first the circular motion. So what is circular motion? So when an object moves along a circular path, it experiences circular motion. Okay, and in this motion, okay, it can be uniform speed or non-uniform speed, meaning that in circular motion, the object can move with constant speed or changing the speed. Okay, and the direction of the object's velocity, okay, is changed continuously as it moves along the curve. Okay, meaning that the direction of velocity is changed. Okay, when the when it move along the circle, and this velocity keep continuously changing. Okay, as long as the object move in a circular path. So when the direction of the velocity changing is experienced acceleration. And when the object moves along the circular motion, it always experiences deceleration. And the direction of the acceleration is toward the center of the circular path. Okay, so that to retain the object move in circular motion, so we must impose a net force on the object that can change its direction continuously. So we must impose inward force, so which is the has the same direction of the acceleration. Okay, so without the force, meaning that without the force, okay, so when the object move, okay, without the force, it will move continuously straight. Okay, but when it reach here, okay, and there are inward force imposed to the object, so the object will move in circular motion. Okay, and this force must be directed toward to the center of the circular motion. So this, so the inward force, okay, that keep the object, okay, changing the direction, so they can keep the object move in circular path, we call centripetal force. Okay, so they like the moon. So if no centripetal force exerted on the moon, so the moon will move straight. Okay, but because there is a centripetal force, so the moon will orbiting the earth. Okay, and this centripetal force, the magnitude is given by m, mass of the moon, the velocity, tangential velocity of the moon, and the distance from the center of the moon to the center of the circular motion. Okay, in this context, earth, the center of the earth. So to understand how the object, uh, like the moon orbiting the earth, or like the planet orbiting the sun, we must understand first about gravitational force and a circular motion. Okay, so in Newton's third law, it states that for every action there is an equal and opposite reaction. Okay, so in the context of the sun, so the sun, okay, let's say this is the sun, okay, and this is the planet, small one. So from gravitational Newton's law of gravitation, so the sun will exert a force and it attractive force. Okay, at the same time, this planet exert force to the sun. Okay, and both, okay, so both have the same magnitude of force, which is this force is we call gravitational force. Okay, so based on third Newton's law, the sun exerts gravitational force on the planet at the same time, so it pulling toward to the sun. At the same time, the planet also exert equal but opposite direction of gravitational force on the sun. It's also pull the sun toward, but here the sun is very massive. So because it has 99.8% mass of the solar system. So meaning that the force exerted by the sun is more noticeable. Okay, so that's why it's not moving. Okay, instead of the planet. Okay, so because the object, okay, move, okay, the planet move, it has naturally move. So when there is a gravitational force from the sun, so there is a single force, okay, acting on the planet, which is inward, but this planet naturally move. It has V here, so the object will change the direction and move in the circular motion. Okay, so this is why the planet move in the circular motion, orbiting the sun. So the same concept is applied for the case of moon earth system. So the moon orbiting the earth because of the centripetal force. Okay, centripetal force, which is the centripetal force is due to gravitational force exerted by the Earth to the moon. Okay, and the Earth is massive compared to the moon. So the moon naturally moves, but because of this centripetal force, due to the gravitational force exerted by the Earth on the moon, so it's changed the direction. So the direction change, okay, due to the force of gravitational force. Okay, so that's why the moon keep moving in the circular motion. Okay, so centripetal force, the magnitude of centripetal force, okay, is given by mv square over r, which is m is referring to the orbiting object. Okay, this one. Okay, and v is referring to the tangential speed of the object, and r is the distance from the center to the center of the object. Okay, this is r. Okay, because the only net force acting, so the only net force acting on this object, okay, is gravitational force, which is the gravitational force is given by g, constant, mass small m, the orbiting object, okay, capital M, okay, at the center, the distance between both objects. Okay, so because the net force, okay, the net force acting on this orbiting object, just single force come from gravitational force, so the centripetal force is equal to the gravitational force. Okay, so from second Newton's law, F equal to ma. For the circular motion, the summation of F equals to mv square over r. Okay, so for circular motion case, and we know the net force acting on the object just come from gravitational force, which is Fg equals to mv square over r. So it become like this. Okay, and we rearrange this equation, so we obtain that the v is equal to surd gm over r, meaning that the velocity of the object orbiting the center of the circular path is just depend on the mass located at the center and the distance from mass and the orbiting object. Okay, so if the object further away from the sun, okay, so it will move slowly. Okay, it will move slowly. Okay, so when the r is higher, meaning that the v will move slowly, meaning that the mercury, okay, located near to the sun move faster compared to the earth. Okay, Mercury is located near to the sun. Okay, it moves faster compared to the Earth, located far from the sun. So to calculate the period, orbital period, okay, so we must consider first the circumference of the orbit. Okay, so this is a orbit. Okay, so circumference is equal to V times T. T is a period. Okay, so period. So period meaning that it's time taken for one complete revolution. Okay, so to find the circumference, so V times T. Okay, and we know that the circumference is equal to 2 pi r. Okay, so 2 pi r. So this one, V times T, and also there is one equation to obtain the circle. So that we rearrange the equation, which is Vt is equal to 2 pi r, and we obtain the t, the period is 2 pi r divided by velocity. Okay, so we assume this v is a constant speed. Okay, and then we substitute v, okay, which is we obtained from previously from the relationship between vector force and gravitational force. So we obtain that the V is gm over r. Okay, so we substitute this equation previously to this equation 3. And then finally, we can obtain that the period, orbital period is given by 2 pi divided by surd gm times r to the power 3 divided by over 2. Okay, so this P orbital period based on the object orbiting uh, in the perfect circular, but in reality, actually, most of the planet is moving not in perfect circular, it's moving in elliptical orbit. So we have to make some adjustment to this equation where the period finally become, we replace the radius here with the semi-major. Okay, so this one we will discuss in Kepler's law. That's all. Thank you.